Okay, so factoring flowchart. So ultimately, I want you to kind of not be too reliant on this, but if you ever get stuck, this could be a good way to help you out. So ask yourself how many terms you got, and then you answer a bunch of other questions afterwards. Like, for example, if I have two terms, right? 5x squared minus 45. If I look at the flowchart and realize, okay, I got two terms. Are they in common factors? Yes. Take them out. And does it represent the difference of two squares? So let's take a look at that first example. Are there any common factors between 5 and 45? What's common? 5. Pull it out. Now, difference of two squares. What that means is that is there a subtraction in the middle? Yes. And are x squared 9 perfect squares? Yes. What's the square of x squared? How do you break apart x squared? It's just what x and x, right? How about 9? 3 and 3. And you make one negative, one positive. Now it's factored. And look in the flow chart, that's exactly what we did, right? We did a minus b times a plus b, right? And we're done. So that's factorable, and that's what we got. Why do we care about factoring? You'll see in just a little bit. But for now, it's just a skill that we're just going to just keep working on because it's probably one of the most essential skills that we get out of Algebra 2. Some people would disagree with me, but I think factoring is a big deal. So for B, okay, so you have three terms. So I look at my flow chart. Here's my flow chart. Now I have three terms, right? Before I get too carried away, I look for common factors and pull them out. What are my common factors here? Pull them out. So it's law of its division, right? So 3x. So it's x squared plus 5x minus 14. Okay. Now, the next part of the flow chart says, are the first and last terms perfect squares? They're not. Because 14 is not a perfect square. Because there's a special kind of factor that goes with that. Is the leading coefficient 1? It is. Because you just have x squared. So then you just factor using the diamond. The diamond, because you guys done CPM, so you guys should be pretty comfortable with that. Do you guys remember how this works? What do you put up top? You guys know? You guys remember? You put the last term, negative 14. And do you guys know from the bottom? 5. Well, yes, you can put 5x. I'll put 5. And then your goal is to find two numbers that multiply. You have to multiply this, but add to this. There's not really that many options, like negative 1 and 14, right? Negative 2 and 7, 1 and negative 14, 2 and negative 7. Those are four pairs that all multiply negative 14. Which of those four pairs adds up to 5? Negative 2 and 7, right? Now, granted, you might be given some crazier numbers, not crazier, but numbers have lots of factors, like 60 or 80. So you might have to take a little more time. But if you think about it, there are not that many options. Thank you. And that's it. 3x, x minus 2, x plus 7. Now, if I were to multiply this out, I would get back to the original expression, right? Because that's the whole point of factoring. It's the opposite of multiplication. Like if I were to FOIL this, right? X times x, x times 7, negative 2 times x, negative 2 times 7. If I multiply all that out, and then distribute the 3x, I'll get back to what I originally. So for C, what's common here? What they both have in common? 2 and y, exactly. X squared plus 4. Unfortunately, there's nothing you can do about that. X squared plus 4 is what it is. Leave it alone. It's difference of two squares, not sum of two squares. So you leave it alone. That's all. Okay. Now let's take a look at number 2. So why do we care about factoring? We care because this will help us solve for x-intercepts. Because ultimately, you're going to be graphing this kind of stuff, right? And if you set y equal to this, right? great. You have an equation, a relationship. But if y equals 0, that happens on the x-axis. So what happens is that when you factor and solve, it's going to give you x-intercepts. So solve for x, those are going to be x-intercepts. In a word problem, they'll have more context to it. I'm going to talk about that with you guys in just a little bit, because that's also another reason why we care about factoring. And factoring is also just one of those skills you kind of need to pull out of your back pocket quickly as you get to more advanced math, like pre-calculus and calculus. Just has to be natural. So factoring, we don't want it to be an issue. It's got to be very natural by the time you finish algebra 2. So in this case, I'm going to do the diamond, put 81 and -18. There's nothing common to pull out. It's 3 terms. The leading coefficient is 1, so go straight to the diamond. Well, we're going to do diamond anyway, even if the leading coefficient was not 1. What two numbers multiplied 81? Yeah, exactly. Both -9s. So it's going to be x minus 9 times x minus 9. Or just 9. Because one of those two factors has to equal 0. Another thing I could have done too, I just realized it, were the first and last terms perfect squares? They were, right? 81 is a perfect square. X squared is a perfect square. So I could have just factored it more compactly as a minus b squared. And look, if you look at a little asterisk there, it says that you can do this process as long as the middle term is twice the product of the square roots of the first and last term. What else is a mouthful? But the square roots of x squared and 81 are x and 9 respectively. Double that is 18x. And yeah, that's what we get. So you can just do x minus 9 squared, just square root them, because you're going to get -18x after you FOIL. Okay, here. What two numbers multiply to -63 in F2? I know it's quite a bit. There's -163. Yeah, you got it, Emma? Good, yes. And one's got to be negative. We'll put this out negative next to some. Good. Yeah, I mean, there's like, you can't divide by 2. So if you can't divide by 2, you can't divide by any even number. So forget about it. But you could do -3 and 21, you're getting warmer. And then -7 and 9, you hit it. And you can use a calculator, by the way. Yeah, we give you guys 4-function calculators for this kind of stuff. So if you have to like do a bunch of division situations, that's totally fine. So you get x plus 9 and x minus 7. Very good. Okay. And now here's why do we care to solve this? Because either this has to equal 0 or this has to equal 0. Either x plus 9 has to be 0 or x minus 7 has to be 0. Because anything times 0 is what? 0. Even if you have like 100 factors, if one of those factors is 0, the whole thing is 0. So what makes that happen? Either when x is -9 or when x is 7. Either way, you will get 0 for the solution. So easy peasy. All right. That's easy. It's called FOIL. FOIL means first, outer, inner, last. So you get 3x squared, -21x, positive x, and -7. Combine the like terms, and you got to expand it. And if you want to get back to how it was before, then you factor. Because multiply and factoring, they're inverse operations. No, Now, I think you guys have done it this way in CPM, and we do it this way in Algebra 2 as well. You guys use the box instead? Yeah, actually, I should be doing that with you guys because we're gonna do that for number 4 for sure. And you guys know how the box works? You multiply the corresponding parts, right? And then you just combine whatever's like terms. See, it's still the same thing. It's just more organized. So actually, I'm going to use that for number 4 because I think it's a really good technique. So there's FOIL, which is an acronym for first, outer, inner, last, or first, outside, inside, last. That's how your parents or I learned it many years ago. And a lot of math teachers will just kind of just naturally say that. So maybe you've heard that, but in CPM, I don't think they really use that term. They use a box instead. So we'll stick with the box. So next up, AC method is just basically just a diamond. But it's called the AC method because you put A times C up top and B down below. And generally speaking, a quadratic expression is thought of like this: AX squared plus BX plus C. So A is 5, B is -17, and C is 6. So if we do AC, I get 30. B is -17. All right. What two numbers multiply 30 and add to -17? Emma? Good. You're a factor machine today. Perfect. Yeah, that's right. Correct. There's a whole bunch of options. There's 1 and 30. There's 2 and 15. There's 3 and 10. There's 5 and 6. And then the negative counterparts. 5 and 6, we kind of overshot it, as well as 3 and 10. But 2 and 15 work. Good. However, you're not out of the woods yet. Because you can't say x minus 15 and x minus. Don't write this down. Because if you were to multiply this out, you don't get back to the original expression. You don't get the 5x squared, right? And plus, you don't get the plus 6, you get plus 30. You do get the middle term, but that's it. So instead, we have to do the box. And you're going to go in the opposite direction now. You don't know the outside stuff. You know the inside stuff. Excuse me. So now I got 5x squared. I know I got 6. And this right here is -17x split up. We actually call it splitting the middle term because the middle term is -17x and you split it. How did you split it? In this manner. Why do we split it this way? Because they multiply a third and add to -17. That's why we split it that way. So you can put -15x and -2x in the other corners of the box. Now this is where the fun begins. Your task is to figure out what to put on the outsides. Well, if you think about it, let's look at that first row. What do these have in common? 5x squared -2x. What do they share in common? These two. Just an x. How about the first column? What do they share in common? 5x. Good. So you have x and 5x. Great. And that multiplies a 5x squared. Totally, right? Now the rest is it should be smooth sailing. What are you going to put right here now? What do you multiply 5x to get to -15x? Just -3. And what do you multiply -3 to get 6? And it's consistent. X -2 is also -2x. Everything works out lovely. X minus 3 and 5x minus 2. And you're not asked to solve, so you just leave it like this. If you're asked to solve, then x equals 3, x equals 2/5 if it says set equal to 0. But yeah. Those are more advanced factoring questions. Well, we do more advanced stuff in Algebra 2 for sure. But in terms of quadratic equations, that's as advanced as it usually gets. Let's try a couple more times. Let's try a word problem. And then I'll have you guys do some practice problems after that. All right, so let's see here. So that will be, actually, let's go to my flow chart. We have three terms. There's nothing common among these because 9 doesn't share a factor with 4. And 12 does share factors with 9 and 4, but 9 and 4 don't share anything. So there's nothing common here. So I'll go down. Are the first and last terms perfect squares? I think they are. Is 9 a perfect square? Yes. Is 4 a perfect square? Yes. So you're able to factor it by just taking the square roots of the first and last terms. As long as the middle term double the square roots give you the middle term. Because the square roots are 3y and 2. The product is 6y, and double that is, of course, 12. Or you could write it like this. So what happened here, we recognized that the quadratic expression is a perfect square trinomial. That's what happened. And that's what I was able to kind of do quickly. And how did I recognize it? Because the first and last terms are perfect squares. In the middle term, right? Double the middle term. Sorry. Double the square roots. Sorry. The square roots multiplied, double that is the middle term. That's what I meant to say. Just got to be careful with my words. But you could have done this too if you wanted to. You don't have to write something. If you wanted to, you could have done 36 and 12, 6 and 6, box, 9y squared, 4, 6y, 6y, 3y, 3y, 2, blah, blah, blah. I mean, you could have done all that stuff if you wanted to. But I'm gonna have to do that for B. And B is a little crazy. Negative 80 and 38. Okay. I told you 80 is one of the crazy ones because there's a lot of possibilities, right? 1 and 80, 8 and 10, 4 and 20, 5 and 16. What do you guys think? And we got it? Yep, 40 and 2, got it. Negative 2 and 40. Yep. But we got to do the box because the leading coefficient is not 1. Again, according to my flow chart, I've been pretty consistent using the flow chart repeatedly now, right? The leading coefficient is not 1. So I go down this path, right? Let me clear for a moment. I go down this path. Right, that's my path. And grouping is an old way of doing it. I'll call this the box method. This is a dated flowchart from a long time ago, so I need to update this. Okay, so speed about Zoom, I can do that. All right. So 8c squared, negative 10, negative 2c, and 40c. Awesome. All right. What can I pull out from the first row? What's common in the first row? 8c, and this has to be c. This has to be negative 2. I should have done something else earlier on, but it's okay. And that will be 5, I think. I forgot to pull out a common factor. That's my fault. Was there something common beforehand? Yeah, I should. It's okay. It's not a big deal. Just gotta take care at the end though. Because yes, I'm not wrong. I'm correct with what I've done. But if I say the factor completely, then I'm not giving the full story, right? I gotta take of that too. Yeah, my apologies. There we go. Cool. Good. Okay. Okay. This will be the last one, and then we're gonna do some problems, and then we'll take a break when I see those guys getting out. A rectangular picnic site measures 24 feet by 10 feet. You want to double the site's area by adding the same distance x, so lengthen the width. Write an equation representing the new area of the picnic site and solve for x. Okay, it's a little tricky. So let's say this is the rectangular picnic set, right? And you're going to expand this. So right now, this is 10. Actually, let me do it on the inside. Let's switch colors too. Okay, then what you're gonna do is this. This is the part that's a little tricky. You're gonna expand it. So that means that this becomes 2x plus 24. And this becomes 2x plus 10. Do you guys see that? Right? Because if this was the original picnic site and you expanded it, right? It's kind of like if actually a great example would be you guys go out to the garden where we have like the goats graze sometimes, where they have like all the vegetables and cactus and whatnot. So there's this area right by the corner of Emily and Paul Priso, Donahoe Road, I think they call it. Where they have this area where the goats can graze. But what if Slapter and Doyle wanted to expand it, right? So they would push the fence out, right? So they want to expand it. That's what we're trying to do here. We're trying to expand it. But they want to expand it by the same distance on each side, right? So they want this increased by X, this increased by X, and so forth, right? I think that's the question's asking. I don't know. But I like it because I want to make this a little more complicated for you guys. So you want to double the area. So right now the area is 240, right? The original area is 240, right? Because I just did 24 times 10. But the new area has to be what, guys? If you want to double it, it becomes what? 480, exactly. And what's area? Length times width, right? Well, what's my new length? That. What's my new width? That. And that's what I'm going to work out. Now, can I do this in Desmos? 100%. Do I want you to do it in Desmos? No, because I want you to use my hand, right? I want you to practice doing it by hand. Okay. So now that I have a diagram, I think I should be a little more clear with the wording. I think I probably would have given you a diagram actually, because I think it's a little confusing. But how to interpret the diagram is another skill, right? I've interpreted the diagram correctly, length times width. I've read the problem correctly. The original area is 240, 24 times 10. The new area is 480 because I want to double it, right? I want to double it up. And that's just area of a rectangle. It's not hard. Now it's all algebra at this point. If you were to multiply this out, two x 24, 2x 10, I should get 4x squared plus 20x plus 48x plus 240 Okay, I think I've done it right so far. Let me know if you see any mistakes. All right. Then what I need to create some space. I'm gonna delete some stuff here. I don't need this either. Let's go to red. Factor out 4. Obviously I did this in my head. So use factor if you need to. 65 of 4 is 7 because half is 34, half of them currently. So that's 4 is negative 60. This should be a pretty easy one to factor. Yes, it is. No, it's not. Wait. Yes, it is. It is. It is. Okay. It's a little tricky. How would you factor that? What two numbers multiply to negative 6.5 is 17? Look, yeah, I mean, you've been on fire today. So one and 6, 1 and negative 60, no. 2 and negative 30, no. 3 and negative 20. But let's go back to negative 3 and 20. So you have that one. This is why we care about factoring. Because now we have a word problem that has some context, right? And you want this equals 0, right? So what values of x will make that work? Definitely 3 or negative 20. I'm not going to go with a negative dimension. That's weird. So there you go, x equals 3. And so you have to expand by 3 feet. So this is important, right? Because let's say they have 4 goats, right? And they know 4 goats can handle the grazing area, but then what if also they have 8 goats? Because we have all these baby goats that happen, right? So they got to double the area. So, it's a good math problem because then they say, okay, well, how much do we need to expand this by on each side? We don't want to, remeasure it. You move by 3 feet on each side and you get your double your area. So it's a really neat math problem that is somewhat practical. So, so that's how you would do it. So that's an excellent word problem. Okay, so let me tell you what you guys are going to work on today. See, it's a lot of problems. I think some of these are kind of messed up. Well, definitely want you guys doing a lot of factoring practice. So I think we're going to do 1 through 18 all here today for 4-3. And for 4-4, 1 through 17. Some of these are going to go by pretty fast, just so you know. Definitely 4-3 goes by pretty fast. So yeah, so we're going to do 4-3. Actually, I'm going to do some of these with you guys. I'll speed things up a little bit. So now we're going to say can't be factored. This one's a perfect square trinomial. This is also a perfect square. Here that's the difference of 2 squares. You're just going to do your. I don't mean to cross it out. That's confusing. Sorry. Here's the diamond. You're solving. So you need to move these over to the other side. Solve for x. Here again, just factoring. Yeah, factoring so it's easy to graph these. We'll talk about graphing maybe tomorrow. And then, yeah, a couple word problems. I think those worked out fine. I think they should be okay. So I'll do diagrams for 17, 18 in just a moment. Probably after the break, I'll do that. So anyway, go and work on those. We'll do this for about 5 to 10 minutes and then we'll take a break.